Today we have Talip from Citrea, who is going to teach us how to deploy a smart contract on Citrea. And I also think he's going to give us a little bit of a blockchain 101, which will be really good for any beginners.
So I'm a DevRel engineer at Citrea. I used to do some engineering stuff at Citrea, and then now I'm mostly talking with devs, especially the brilliant devs coming from various places all around the world, including Encode Club as well. And I primarily try to get as much as feedback and try to fix as much as what we need for the tech stack for the developers, and also try to help them launch products, write some code, work on some ideas and stuff like that. So the thing is, like, I didn't want to put a full presentation. Instead, I will simply explain what we're doing and then like what's going on all around, like what are all these crazy tech and what will you need in the workshop. And then we will write some simple code and then deploy it and then check like what does it do. And then at the end, if you have some time, maybe I can give you some one or two more tips that might be helpful in the hackathon. So we're building Citrea, and Citrea is essentially a blockchain, or more specifically, we call it a rollup. I will explain to this in a minute. What is a rollup? What is a chain? What's the idea? So to start with, really simply, like all of the idea comes from like essentially all the fundamentals goes back to Bitcoin. And to really quickly summarize this up, so it's like in the modern traditional systems, what you have is a bank, simply. Like think of this as a computer. And then this computer is basically accepting money and then giving out some money and some applying some credits and whatever. And like this is pretty much the traditional finance that you get your wages and then you use as bank accounts and stuff like that. But like if you really check the technology behind it, it's just a couple of computers. Even like you can think of it as a huge, gigantic computer that does all the stuff. And this computer is at the hands of some people that has the authority for your all funds. Like let's say you have some white cash in the bank sitting, and then there might be some angry people who will just share your funds and then or will be angry and then just by some order whatever you might be supporting as an idea, or whether as a result of financial crisis which happened, then like they may refuse to give you your money, you may be unable to use your money. So essentially you're out of your financial freedom in this setup, even though it's working from time to time. There are some really big problems. And like with the idea of cyberpunks, with the idea of Bitcoin, you essentially try to get rid of these authorities, uh, being able to harm you in that sense. So you're trying to get your financial freedom. This is actually like the whole idea of what we're trying to achieve as an industry. It's like financial freedom. Hopefully I typed it correctly. I'm not sure. So the idea is essentially, for example, with the Bitcoin, there is no admin. That means there's a bunch of computers which has no admins, and they're always talking with each other from time to time. And like they're basically based on an algorithm deciding whose money is where and like how is it going. And you pay less, and since there is no admin, then you can own your money unless like if you know your private keys, if you know your keys, then everyone knows that how much money you have in your student's account, and then you can use it whatever you want without the um, without being without the fear of any problems by the authorities or by some malicious people. So this is the whole idea actually. But the problem is like the more computers you have, the securer this gets. But the more computers you get, then the slower it gets. So it is like um, to have such systems as much secure as possible, you ideally want more people to be joining the network and controlling and checking if everything is correct. But this comes with the problem of computers talking to each other in a network, which is like once you do a transaction, for example, once you say, I want to submit some money to someone, then this message needs to be relayed to every computer in the network in one way or another. And this is not like this increases security, but it's not the fastest way. And this problem is generally called like scalability problem in that sense. Like you can think of it as scalability. And like this is a common problem. They call it blockchain trilemma. Essentially, at the end of the day, the more computers you have, the less it scales. It comes with the problems. So to fix this, like there are some ideas. Like some people design systems that have less computers but more computation. That you, at the end of the day, sacrifice a bit of trust and then make it faster. And some people disagree, just use Bitcoin or whatever. Everyone is fine. And all of these computers, like you can run that, like there's some code running on. So in the banks, for example, there's a, let's say, I don't know, deposit function. And then there's a withdraw function, whatever. Like these functions have their own algorithms that runs and that gives you money, takes the money out whenever you do some transactions. Similarly, you can also program these computers in this financially freedom-enabled systems. Like in Bitcoin, you have some programming language going on. And the same goes on for the Ethereum as well. So like in the Ethereum computers, like in computers that are running Ethereum, like there's different software that can be runnable. So I'm trying to oversimplify. I might be oversimplifying a bit, like, but bear with me in that sense. So like you can configure your custom logic, and in fact, like if you were to check some, all you read all the token stuff, all the token stuff that you hear are like, you know, uh, all the token stuff that you hear in Ethereum is just some code. It's just if you were to go some documentation, you will see that at the end of the day, it is just some code that has some custom logic that enables you to burn some money and get some tokens. And it is just the consensus of people that designs these tokens that gives its value. Like you can assign any name, you can assign any supply. But at the end of the day, the algorithm is just like Python, for example, just like C++ or whatever you use. There is a computer, there is a software language, there is a programming language that runs that you can use to design algorithms and systems. The same goes for Ethereum as well. So there is there's basically some code that you can run, and with these codes you can basically customize custom financial systems that you can utilize. And this is important. Why? Because so we know all the finance going through the like banks and stuff, but we also want the similar functionalities. We also want to get a loan in these blockchain systems without admins. So in that sense, what we use is smart contracts, we call. Like that's the term of smart contract. And smart contracts are basically some pieces of code that you can upload to these computers and that they will run forever without an admin, like depending on your programmability, depending on how you program them. But essentially, like there are some code pieces that always runs whenever you trigger them, whenever you call them with a transaction. And this is super important because using this, we can implement many other different designs. Like you can implement tokens, you can implement NFTs, you can implement decentralized exchanges, which we call DEX. That means like there are some price pairings that you can always swap some digital money with some other digital money, or swap some NFTs with something, or you can take a loan. We call them lending borrowing systems. Lending, borrowing. And at the end of the day, all of these has some smart contracts running on. And these smart contracts are heavily using the Solidity programming language we call. It's called Solidity. Solidity. And this really matters because like Solidity is designed for this purpose. And so coming from this to why all of this matters in Citrea is essentially Citrea is a smaller blockchain I can call. Like Citrea is also a blockchain that many people can run some software and check. And in this software, like you can also run some Solidity codes that I show you here, which is the pretty much same with what's going on in the Ethereum world. And this Solidity code runs inside a system called EVM. And so Citrea is also EVM compatible. So on summary, what I mean is like any software that runs for the Ethereum world, whatever, is pretty much runs in the same way that Citrea runs. So you can use your Solidity programming language codes in Citrea. So you can learn Solidity during this hackathon, and then you can implement programs for Citrea. And okay, so I talked about all of these, but then the question is like, what does the Solidity code look like, or how do I start? So let's jump into this actually. So to use Citrea or to use any other chain, you need some funds and you need a wallet. So this is MetaMask wallet that I use. You can also install one. You can also check Google, like popular Web3 wallets or whatever. MetaMask is quite heavily used, even though it's not super privacy friendly. You can give it a shot. And you can install MetaMask, and then you need some funds to do some transactions in these. Like if you don't have any money, then you need to always pay some fees to these computers so that they will be incentivized to continue to work. So you need some funds. So in Strea, we are right now running a test system called testnet. And in testnet, you basically give away free funds for people to run programs and develop programs. To do this, you can always visit the Strea XYZ, which is our website. And then you can go to the faucet, and then you can connect your MetaMask wallet. So it will ask me my password, which is not really hard for the test purposes. And then like you can ask some funds from here, and then it will give me some funds now. And also I can check whether I have some funds using this Explorer. So this Explorer is basically all about what's going on Strea at the moment. So there's now 70K transactions going on, some smart contracts. People are calling some codes, running some functions to do some swaps, to do some decentralized exchanges, whatever. So there are some transactions going on, there are some wallets working on. But at the end of the day, like all of the systems continuing to work. So now, like I requested some funds, it gave me 0.005 Strea Bitcoin, which is the currency of Strea, because we use we use Bitcoin very heavily in our system. I can explain later, always in Discord or later. So yeah, so the idea is essentially you need some funds, and now we got it. Like now we have some funds to utilize Citrea. But how to run some simple program then? So you can always visit Remix. It's really good first time visitors or for anyone actually. Remix is really good. It's an all-in-one development environment for the EVM developers. You can always utilize it. And once you open Remix, basically, let me actually delete all of the data so that you can see it a fresh one. So yeah. So when you open Remix, it looks like this. And there's some GPT stuff going on. You can also use it as well. So you see some smart contracts here. And if I were to open one, so I hope this is big enough. So like this is a smart contract. And if you check the code a bit, what it does is like it takes a number and records it into a blockchain among all the computers. And then you can also query it using this retrieve function. So what it does is like there's the library version of it, like which version of the program you're running. You can think of it as a Python version or whatever. And then there's the storage smart contract, which is the logic or algorithm that you're developing. And then this has a number value that inside, like you can store a number, that means. And the store function basically takes a parameter number and then store this value into the blockchain. And then you can also use the retrieve function. And then this function returns a number that takes that basically gives you the answer for your query. But at the end of the day, like this is a really simple smart contract, and you can basically give it a shot to try your first contract in that sense. So deploying a contract means I wrote a contract. Now, like I have the text of it, but I need to basically pay some fee and make this contract exist in all computers that are participating in this network. And then later, I can use this contract that I deployed. I can interact with it. I can send some value, send some money, and then do some custom logic. So let's say if you're going to swap some digital dollars, USDC, to digital euros, EUR, for example, there are some swaps, there are some protocols that does it for you. And like all of these protocols are written in this programming language. You can also check their code and implement something. But all of these needs to be first deployed, first stored by getting some money. And this is what we call deploying, essentially. So to deploy this contract, for example, you need to open this in the Remix, and then you go here, the compiler. First, you need to compile your code. And now it's compiled. That means now you have some bytecode of it. You have some runnable version of this ready to be um, deployed into these computers. And then you can basically open this fourth one, deploy and run transactions. And then from here, we need to pick where we want to deploy this, because like if you are going to open like a list of blockchains, there are like thousands of them. So which one do you want to deploy? And for Remix, the question here is like, you can basically select this environment and then select the injected provider. That means whatever the MetaMask has, because if you open MetaMask here, then you're going to see a bunch of different networks. Like this is Ethereum, this is some people call Linea, and then like this is Polygon, this is Citrea, like there's a bunch of different ones. Now I selected Citrea testnet, and so for Citrea testnet, to be valid in the Remix as well, I need to select the injected provider here. Now it selects the Citrea, and now it shows my current balance. And I have quite some because I generally distribute some funds to people. So if you want to deploy some smart contracts and need some test funds, please type in the Discord so that I can give some of these 70 to you that you can use in case our full set is not enough for you. Yeah. Then now I select my account, and now I click deploy here. So one thing is, okay, I click deploy here. So once I click deploy, it says like, do you want to deploy this? Do you want to pay this fee, which is 0.001 Bitcoin? And now I say, yes, I want to deploy this. And now once I confirm it, it basically sends the smart contract into the world of computers. Now it is there and alive. Now I can use it in any way I want. So if you're going to check this, like here is the storage of this contract. And here are some more values of this. Like if you click, it basically says here, this transaction is like mine. That means this transaction is deployed. And then the hash of this transaction is this. The hash here means like you basically get the summary of the transaction, and then you hash the data. You generate a cryptographic value out of this data that you can always double check for everything. And then this also comes with a block hash. Block hash is something unique to blockchains. So in blockchains, the system basically goes like in every X seconds or per some transactions or per something, the computers basically add some new finalized transactions that are irreversible because there is no admins. And these batch of new transactions are called blocks. And pretty much every computer in this network also will continue to have some blocks as well. So then, yeah, and like the hash of this block is this, and like it is the 3 million. Oh, this is some number pi. Okay, all good. This is like 3142412 is the block number of this, and like the contract address is the address, the slot that computers that live on the network can find this contract. So where does it reside in this network? Like if you were to copy this contract address, and if you were to go to the Explorer, and then if you were to go to like press here, and then you will see that something exists here. Like there's some contract. And since this contract has been published before many times, we know that which contract is this. Like it shows me the code that is alive at this particular address. So whenever I want to do something, I need to use this address and say to the computers that in this 60 blah 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 address, there's a code alive, and then I want to call the store function of this contract. And how do I do it is on Remix, on the left panel, I have the store function here. So I can always store some value here. So let's say I wanted to store number pi, the first 3 digits. I click store here, and then it basically tells me that, do you really want to submit this transaction in the expense of this amount of value? And I say yes, confirm. And now it submits my transaction to the network and says that this person wants to store the value 314 in this contract. Like they want to change they call this function store, whatever it is, I don't know, they say. They call this with the value 314. And then I just clicked it and I made it. So now what happened is 314 is equal to number. Then let's say some weeks pass and I wanted to retrieve back the value. Then what I do is basically calling this retrieve function. And then it basically tells me the number is 314. So it's like the Remix is actually like quite nice in that sense. It's an all-in-one environment that you can run some code, that you can then deploy some code in the way that I showed you. It's not the only way though. There are different libraries that you can use. For example, there is Hardhat, and Hardhat is like some JavaScript compatible, TypeScript compatible framework, let's say, or library, let's say, that you can use to implement and deploy smart contracts. Or there's also a Foundry Forge that you can use, but these are a bit more advanced in that sense. I generally suggest to go with Remix. So the thing is, like, all these UIs, all these exchanges, like, how do they implement it? Like, because, this code is just some IDE, but then you ideally need some interface to interact with it. Like, let's say if I want to do some swapping operations, then I need to pick one currency, and then I need to pick another currency, and then I need to do some swaps between them. So how this is happening is you can basically query these blockchains, like you can query Citrea using some JavaScript and TypeScript libraries. And in fact, like the Remix also tells me like how can I do it. So like there is a couple of libraries called Ethers.js and Web3.js for JavaScript, and also there's some equivalence in this of this in the Python as well, Web3.py. So for example, if you were to check the documentation of Ethers.js, then and if you were to check the getting started, you just install some packages, just a regular JavaScript, TypeScript package, and then you just write some JavaScript, TypeScript code, and then there's some examples of it. You can even ask the GPT to provide you some examples. And then you can basically interact with the networks that I show you here, just using the JavaScript and TypeScript. And using the same JavaScript and TypeScript, you can also implement some front ends. You can also implement some backends. Then you can combine them and you can make a good front end, you can make a good backend. And then using the Ethers.js in your function, in your code, then you can also interact with the blockchain as well. That gives you essentially an end-to-end working product. And we call these kind of products as dApps. Like you could check dApps here. So it's like decentralized application is another name for it. But essentially, like dApps are some code that interacts with the blockchains, and you can basically make a cool UI UX for this. You can implement some basic backends, but at the end of the day, you can basically make many different platforms. Like let's say just a simple one again, swap USDC. Let's say I don't know who will come. So let's say PancakeSwap. This is like I have no affiliation with them, but like all of this code running here, like you can connect your wallet and then you can swap some currencies between them. And all of this happens through pure programming languages that also use some interaction with the blockchains. Like you can pick any blockchain and then utilize it. So this is the idea of the hackathon, essentially. At the end of the day, you basically get to write some code, some algorithm that is immutable, that lives on a blockchain. And then you can utilize this codes to build any application that you want in that sense. So I would say like this is the overall highlight. We have a couple of more detailed like simple deployment guides in our documentation. It's like if you were to go deployment guide, and then like we also show some the token deployments or hard hat usage here. You can always ask more questions to me on Discord as well, like how to do this, how to do that. There are a bunch of examples in the internet, and you can always utilize GPT. So if you were to go like I don't know, chat.com, this is GPT actually, then you can always say like implement simple token contract and a simple swap contract with the front end and the back end, and then like it gives you some answer, and then you can then basically debug it. You can ask more questions, you can try, but at the end of the day, like this is like this code here is a simple code that you can always use, and like once you ask more explanations, it will give you more explanations. Back in the days, we didn't have that chance, but now we do. And like, especially if this is your first hackathon and trying to understand things, I heavily recommend you to try. Just, try your best. Something will come up, and like you may be eligible for the bounties in that sense. Yeah, this is how all the ideas work, how you deploy dApps and contracts, I would say. And thanks for listening. So two questions. The Bitcoiners do not hate Remix. You can say Bitcoiners only trust Bitcoin because other blockchains have some influencers, some people famous, and then they steer some decisions. And like they only trust Bitcoin because they believe it is the most secure one, which is true. But like they don't really use Remix in that sense for Bitcoin development. The prize pool is we have so there's a $2,000 prize pool in that sense. So we can always like we will basically do not ignore like great projects here, but like if you do your best effort, I believe you will get rewarded. We will see. Like ideally, this is a long hackathon. That means we're looking for some cool stuff that you need to put some work. But again, do your best. Like I recall some days that I made a really not so perfect app and then was something back in the days. It happens. So just try your best. Yeah, deploying a dApp makes you eligible. You can ask any questions on Discord as well to me. We have a testnet right now. So testnet Explorer is here and Faucet is again on the main website. Testnet means the system is almost complete. There are some couple finishing products going on, but it's not relevant to this hackathon. It's mostly internal technical stuff. It won't block you. Again, if you need some funds, you can just ask me on Discord. Deploying with Remix. Yes, so the Remix is like VS Code, you can think, online VS Code that comes with Solidity and Web3 support. So you can think of this as a VS Code and then, or VS Code on steroids, and then you can use this VS Code on steroids to whatever you want. You can deploy to Citrea using this at the end of the day. I want to answer the Mohammed's question particularly in the Discord. I will do it. So we have some differences to stacks, rootstock, and whatever, all these cool chains as well. But we believe like we're building something that is technically the most secure that you can get on Bitcoin, and we believe there's a huge potential. We have some, I would say, credible investors, and we do our best. I think I kept it a bit long. Okay, just in time. So yeah, thanks for listening. And yeah, if you have any questions, you can always type here or on the Discord. We can always catch up. Thank you.
There is one more question in the questions tab from John, who's asking, how would you motivate a person who's into cryptography to get into cryptocurrency work? So like, I guess he means like development like this. So cryptography is a academic subject, do you mean, John, or?
Okay, so the way I understand is like, so on the cryptography side, there's some algorithms that makes essentially the backbone of the internet. Like you secure many things using cryptography, and not only the internet, but of course the Web3 as well. So like the idea is you know some systems that how the hash functions work, how the public key private key cryptography works, how the even to the point that zero knowledge proofs work, or many other stuff that you can utilize in that sense. So in that sense, if you're keen on that, and if you have some particular focus on privacy especially, then I would say like we're quite open to anything being implemented on Citrea in the sense of privacy as well. Because like we're coming from a like back then we used to develop a privacy protocol, something that we deeply value. And again, like the track is build anything. So if you can build some cool privacy protocols in that sense, you're more than welcome. You can also design some algorithms we can check and maybe give a bounty, but uh, like it may not be super easy to put it into the right scope. It might be more challenging. But if you're really good with the numbers and if you're a bit pro privacy, then I would say like check the existing privacy protocols and like what can be built on Citrea, maybe some even though little, some interaction with the smart contracts as well. That's what I would suggest. Um, yeah, but looking forward to chat more as well. Like if you have some ideas, just type me on Discord and we can give it a shot. On the cryptography side, I'm not super fluent, let's say. I know some ideas. I read some papers, wrote a bit, but like we can chat more for the future.
Awesome. Everyone is saying thank you. So one more quick note, as long as there are no other questions for Talib. If you are new to Web3 development and those contracts that the storage, I think it's storage.sol or something that's like the default that comes up in Remix. If you're new to it, like Solidity completely and like new to the EVM, then in the Getting Prepared for the Future Blockchain Hackathon playlist that I sent round, there's a couple of sort of getting started with Solidity EVM basics videos. And they're based in Remix and they cover like the storage.sol contract, and I think changing it a little bit to like show what different things do. So it's definitely worth checking out if you're looking for sort of an introduction to Solidity and Remix as well. And Citrea's documentation is very clear on how you deploy a contract to Citrea through Remix. So you can definitely follow that. You can rewatch this video today and you can watch the videos in this playlist and you should be all set to hack for the Citrea bounty.
Yeah, great. Also, one more tiny thing is like if you trust in your programming skills a bit, and like if you're really encourage yourself to lock all in and then give your best, then you can also check the Guidel, which is one of my favorite websites. It's like you can speed run the EVM developments here. It's not really easy, to be honest, not very easy, but if you're going to give many hours, then you can also check this out as well. And also if you're not super if you have some experience as well, like this may not be very easy, but just as an idea for you. Yeah. See you all, guys. Thanks for listening. Bye bye. Hope you guys have a great hackathon.